Hey guys, this is your TA Youssef, and today I'm going to be doing a problem that has to do with finding the distribution of a random variable. Okay, so let's read the problem together. The problem states, two fair dice are rolled and the absolute value of the difference of the outcomes is denoted by x. What are the possible values of x and the probabilities associated with them? Alright, so the first thing we need to do is determine whether this random variable x is going to be, so x, is it discrete or continuous? So what we're doing is we're taking two fair die and we're just going to roll the set x to be the difference between the two. So since the two die are the sample space of each die is what? It's 1, 2, 3, 4, 5, and 6. And if you take the difference of these any of these two integers, you'll notice that the random variable x will also always be a discrete value. So in fact, this random variable is a discrete random variable. So, all right, so if it's discrete, what kind of distribution are we looking for? Are we looking for a PMF or a PDF? So PMF stands for probability mass function. And PDF stands for probability density function. Okay, so the special property of a PMF is we denote PMF by Px of x, and the special property of it is the summation of all values of x from minus infinity to infinity of the random variable, of the distribution Px of x should equal to 1. And for a PDF, we denote a PDF by Fx of x. This x here stands for x, the random variable, and we say that from x is, I don't know why I was writing a summation. You guys would have already guessed that it's not a summation. It's supposed to be a integral. So for a continuous random variable, we're going to take the integral from minus infinity to infinity of fx of x dx, and that should equal to 1. So the area under the curve for a probability density function should sum up to 1, while the sum of each element of a probability mass function should sum up to 1. So in fact, this is for the discrete case. We use probability mass function for discrete case. We're assigning a probability to each discrete random discrete value. Okay, we do that with a die, right? So the die's outcome is 1, 2, 3, 4, 5, and 6. And if we assume it's a fair die, for example, the probability that x is going to equal to 1 is going to equal to 1 over 6. Okay, so this is an example of a PMF. Okay, this is just one of the values. Obviously, for all of the values, it should sum up to 1, and you would just plot it. For fair die, it would look like this. So it's 0 for all other values. Let's say this negative 3, negative 2, negative 1. 0 is also 0. 1, 2, 3, 4, 5, and 6. These should all be the same value. And if I sum them all up, it should come up to 1. Okay, so now the challenge here is we're given a problem, and we're supposed to figure out what each value the random variable can take on is, and assign probability measures to each one of them. So the way I like to do this problem is, since we're rolling two fair die, the easiest way to visualize the random variable is by making a table to see what the random variable will be at each instance. So let's consider die 1 and consider die 2. So die 1 can take on values of 1, 2, 3, 4, 5, and 6, and die 2 can also take on values of 1, 2, 3, 4, 5, and 6, okay? And if I take the difference between 1 and 1, that's going to be 0. If I take the difference between 2 and 2, that's 0. 3 and 3, that's 0. 4 and 4, that's 0. 5 and 5, that's 0. 6 and 6, that's 0. And basically all you would do is fill in what the difference is for each one. So here the difference between 2 and 1 is 1. The difference between 3 and 1 is 2. 3, 4, 5. I want you guys to fill this out on your own, just so you can practice the problem. But yeah, so you need to just follow the logic. Here it'd be 2, 3, and 4, 2, 1, 1, 2, and 3. You'll start to notice there's also a pattern. And 2, then there is 4, 2, 1, 3. Oh, sorry. It should be 3, 2, 1, 0, and then 1, then 5, 4, 3, 2, 1. So we created our table, and basically what all of this outcomes represent is the random variable x, the difference between two dice roll. Okay, so now we want to figure out what the sample space of a random variable is. That would be, I guess, the first step, right? What values can our random variable take on? So the sample space is what? So our random variable can take on 0, 1, 2, 3, 4, and 5. So random variable can be 0, 1, 2, 3, 4, and 5. And how do we assign the probability measures? Well, for example, for 0, you would count how many zeros are in the table, 1, 2, 3, 4, 5, 6, and then you would divide that number by the total number of elements in the table. So since we're rolling 2 die, each die has 6 outcomes, the total number of outcomes is 36. So the probability that our random variable x is equal to 0 is the number of zeros we see in the table, which is 6, over the total number of outcomes, which is 36. And you do this for all of them. So how many 1s are in the table? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 1s in the table. That would be 10 over 36. And then we would do the same for all the other ones. So there are 8 2s and 6 3s. The probability that x is equal to 2 is 8 over 36, which is equal to what? Simplifying that is 2 over 9. And then there were 6 of those, right? It's also equal to 1 over 6. And then I think there's 4 4s and 2 5s. So, and since to double check our answer, well, earlier I showed you this summation, right? For a PMF, the summation of all of the probability measures for each of the outcomes should equal to 1. So here we have all the probability measured, here we have all the outcomes. So let's sum them all up and make sure that it equals 1. So we have 1/6 plus 5 over 18 plus 2 over 9 plus 1 over 6 plus 1 over 9 plus 1 over 18. Okay, and this does indeed sum up to 1. Okay, so we got our PMF. Let's plot it. So we label this like this, Px of x. This is x. Say minus 2, minus 1, 0, 1, 2, 3, 4, and 5. Okay, and then 6. So anything outside of the sample space, which is 0 through 5, should be equal to 0, right? And it's discrete plot, so we plot it like that. So 0 is 1, 6, and so is 1 over 3. So we can, like that. Okay, and then you have 5 over 18, which is like a little bit less than a third, and 2 over 9. So we should be labeling these two so the plots are clear. Oh, sorry. Wrong label. Be 5 over 18. It's a little less. This is 2 over 9. This is 1 over 9. This is 1 over 18. Okay, so that is how we would plot the PMF. Now let's plot the CDF. So for a discrete random variable, the CDF is going to end up looking the same. Not exactly the same, obviously, but it's going to be pretty much the same kind of function with a little bit of variation because basically for the CDF, how do we find the CDF first of all? So the CDF is the probability that our random variable x is less than a given point x, okay? This gives fx of x, which is the CDF. CDF is the cumulative distribution function. Okay, so how do we determine that? Okay, we determine that by choosing a point x on the PDF. Let me change colors here so you can see it better. So for example, I'm gonna choose a point x that's less than 0. And I'm gonna sum up all the probabilities before that point. What's the sum? What is the probability that x is less than 0? Should be 0, right? Because the only values that our discrete random variable can take on are 0, 1, 2, 3, 4, and 5. So if we're anywhere less than that, the probability for that is going to be 0. So the way you would draw the function so far is up until 0. So this is fx of x. Up until 0, that probability, the value of that function should be 0. Then something happens at 0, obviously. At 0, we see a probability measure of 1/6. So at 0, we will jump up to 1/6. Okay? And now for the next point, let me erase a little bit here so you can see it a little clearer. Okay. I'm going to choose a point x now that's between 0 and 1. And now if we look all the way to negative infinity, so we always look to negative infinity when we're doing this. The sum of all the probabilities is 1/6 because we only see this one probability measure here at x equals 0. So this until we get to 1. Okay, let me just label all these now. It's 1. This is 2, 3, 4. So until we get to 1, this should remain at a constant of 1/6. Then something happens at 1. At 1, we see a probability measure of 5 over 18. So now we're going to jump up by a value of 5 over 18. And so that this point here is going to be 1/6, which is equal to 3 over 18 plus 5 over 18, which is 8 over 18, which is 4 over 9. Okay, so we'll jump up to there. Then when we get to 2, I'm not going to keep drawing the same thing that I was just doing, but now when we get somewhere between here, we sum up 5 over 18 and 1 over 6 again. So until we get to 2, it should stay the same value. And then at 2, we'll see the 2 over 9. So we add 2 over 9, and that'll give us to 6 over 9. And we will keep going until 3. And at 3, we're going to add the 1 over 6. So 6 over 9 plus 1 over 6. That would be 12 over 18 plus 3 over 18, which is 15 over 18, which is 5 over 6. So we'll get to 5 over 6. And then we'll add a little bit more, and then a little bit more, and then it should converge to 1. Okay? So this is, you don't really, like, if I were you, I would always label these points, so label. I'm not going to do it now because I don't feel like it, but basically the idea is each of these jumps here, each of these jumps is the value of the probability measure at that possible outcome. So if you look at the probability that x is equal to 3, it's 1/6. Well, that's the value of the jump. So the CDF basically just sums up all the probabilities at a given point x that are to the left of it, coming from negative infinity. So all the probabilities to the left of it. Okay, and let me just restate these probabilities. These properties of the CDF. So for the CDF, some useful properties that you should know is that if you take the limit as x goes to negative infinity of the CDF, this should equal to 0. And if you take the limit as x goes to infinity of the CDF, this should go to 1. So, okay, that wraps up this problem. Make sure you also know how to do this for the continuous case. You could be given a random variable where that's going to be continuous. It might not exactly be a word problem like this, but you should be able to determine the PMF and the CDF, knowing the properties. Okay? All right, thanks for watching, guys.